Welcome to The Explainer. Today, we're diving into a new AI model that's trying to solve one of the biggest headaches in artificial intelligence. That painful choice between having incredible brain power and incredible speed.
So let's just jump right in with the big question, right? For the longest time, it's felt like a law of physics in AI. Why can't the smartest model also be the fastest? Why are we always forced to choose?
I mean, this has been the dilemma for years. You've got these frontier models. They are the supercars of AI. They can do these breathtaking feats of complex reasoning. But they are incredibly slow, outrageously expensive, and need entire server farms just to run. They're just not practical for the kind of fast, everyday tasks we need them to do.
But today, we're going to unpack a brand new model that might just break that trade-off. We're going to start with that power dilemma, then we'll meet our new contender, uncover its secret weapon, see how it actually stacks up against the big guys, and then, most importantly, talk about what this changes for all of us.
All right, let's meet the star of the show. This new AI is called Step 3.5 Flash, and it is making some serious waves. And you know, right out of the gate, its creators made a really bold claim. They said they built a model with agentic intelligence. That's a fancy way of saying an AI that can actually do stuff, not just talk, but without that crushing, bank-breaking computational cost.
So really, the promise is simple but huge, to give us the raw intelligence of a giant heavyweight model, but with the speed and agility of a world-class sprinter. It's trying to be the best of both worlds.
Okay, so how in the world does it pull off this magic trick? How can you have this enormous brain but run it like it's something small and nimble?
Well, the secret sauce is a really clever design called Mixture of Experts, or MOE. Now, instead of firing up the entire massive neural network for every single little thing, MOE acts like a super smart project manager, sending each task only to the small, specialized teams that are perfect for the job.
Here's a great way to think about it. Imagine a massive consulting firm with hundreds of specialists. You've got lawyers, engineers, marketing gurus, the whole shebang. If you have a legal question, you're not going to waste everyone's time by asking the entire company, right? No, you go straight to the legal department. Mo.io does exactly that, but for AI.
And here's how that process works, step by step. A task comes in. A little router inside the AI takes a look and says, okay, for this specific problem, I need you, and 6 other experts. It picks the best little team of 8 specialists for the job. Only that small group gets to work, while everyone else just chills, saving energy. It's incredibly efficient.
Now, this whole setup allows the model to have a massive total knowledge base. We're talking 196 billion parameters. That's where it gets its deep understanding and its powerful reasoning skills. It's a true giant.
But, and this is the flash part, for any one task, it only activates about 11 billion of those parameters. So you get the wisdom of the 196 billion parameter giant, but with the speed and cost of a much, much smaller model. It's a genius way to have your cake and eat it too. Okay, that all sounds fantastic in theory, but the real question is, does this clever design actually hold up in the real world? Let's see what happened when they put Step 3.5 Flash in the ring with the industry's reigning champions. And let me tell you, the researchers did not pull any punches. They put this model through a gauntlet of tests, benchmarking it against some of the biggest names you can think of to see if the theory really works in practice. This chart pretty much tells the story. Step 3.5 Flash is the one in the blue striped bars, and it's going head-to-head with behemoths like GPT 5.2 and Gemini 3.0 Pro across a whole bunch of really tough challenges.
And look at these results on reasoning. We're talking about incredibly difficult math and coding problems, the kind of stuff that is a true test of raw intelligence. And it's not just keeping up, it's right there at the absolute top of the pack, sometimes even beating models that are way bigger and more expensive.
And it isn't just a brain in a jar. When it comes to those agentic tasks, the stuff where an AI actually has to do things like write software or navigate a website, it proves, once again, it's not just smart, it's incredibly capable, posting scores that put it firmly in the top tier.
Now, anyone in the field will tell you building a mixture of experts model this big is notoriously hard. They can be really unstable and just fall apart during training. So how on earth did they manage to build this one so well?
Well, they did it with extreme, almost unheard of stability. Just look at this graph. This shows the training process over 17 trillion tokens of data. See how smooth that curve is? It's practically perfect. The paper even notes there was only one single tiny hiccup in the entire run. Honestly, that is a massive engineering achievement in itself.
So let's step back. What's the big picture here? What does it all mean? Why is a model that's both this smart and this efficient such a huge deal?
Because this could be a real game changer. It means we might finally get top-tier AI agents running right on our phones and laptops. It means faster, cheaper, more powerful tools for developers and creators. This architecture could unlock a whole new wave of apps that have to think and react in real time, something that's been basically impossible until now.
This quote from the paper just nails it. It's about building a high-density foundation. In other words, packing more intelligence into less computing power. And that is the key to finally getting these sophisticated AIs out of the lab and into the real world, where they can actually start working for us.
And that really leaves us with one final exciting thought. For so long, we had to pick one, smart or fast. Now that line is starting to blur, the real question becomes, what amazing things are we going to build when the most intelligent AI is also the most accessible one?